I'm back again. Hey, before we get into sedimentary rocks, guys, I wanted to show you something from the last unit because I talked about how different magmas, the rate of cooling, how it makes different rock formations. Well, here's a great example of a very, very fine, not quite rhyolitic, but very, very fine grained igneous magma, granite, and also not very fine, I should say fine, more fine than the coarse grained granite that's right here. So the question is, which one cooled faster? And the answer is this magma must have cooled closer to the ground surface because this magma right here cooled faster because of its small crystal size compared to the rock of the country rock, the mother rock that was already there, must have been intruded by this magma dike, this cross-cutting magma, and it cooled more slowly, producing a coarser granite, evidence of that larger crystal size. The larger the crystals, the slower cool. So on your exam, they might give you a question with very, very small crystals versus very large crystals. Which one is evidence of more intrusive plutonic nature in English? Which one cooled slower? The one with the larger crystals. Beautiful. Now, these guys right here. Sedimentary rocks. Now, personally, I love sedimentary rocks. What I just had in my hands was one of the oldest fossils on the planet. It's actually called stromatolite. It's on page 8 and 9 of your reference tables. Going to hoist it up again. Here it is. Can you see the swirls on it, the swirly nature of this? That's actually algae mats. Those are algae mats that actually solidified with mud in the ocean to actually form this solidified slime. And I say solidified, I shouldn't use that word because that means it cooled out of magma. Actually, it just sort of all the water evaporated away, leaving this slurry slime of organic matter behind. Billion-year-old fossil remains called stromatolite. I mentioned I love sedimentary rocks because sedimentary rocks tell a story. They tell a story of what was in the area. I can hold this up, and this right here, we see these little lines going through this rock. These are actually burrows formed by worms that then fill with sediment. So this substrate shows, this rock matrix shows that there were worms present here, and they burrowed through this rock, worm burrow fossils. This right here is sedimentary. It's actually hardened dino poop, showing the presence of dinosaurs out in the Morrison Formation out in Colorado. This right here, oh my gosh, look at it. Littered with fossils all over it, telling a story about the life that was there. So in essence, I can even show this, even the waves of the sea, demonstrating themselves in rocks that form at or near the Earth's surface. Now, when we talk about sedimentary rocks versus non-sedimentary rocks, sedimentary rocks are either made up of sediments from the land or they're made up of the leftover parts of water evaporation at or near the Earth's surface. Most rocks on Earth actually are non-sedimentary. Most make up underneath the actual surface of the Earth. Going as deep as solid rocks, going as deep as 100 kilometers, about 62 miles in depth, making up what we call the lithosphere. In fact, most of the lithospheric plates for our next unit, topic 12, when we talk about plate tectonics, are those lithospheric plates are either granite or basalt rocks, which are igneous in nature. And most of the rocks that just form the thin veneer, that thin layer on the top of the Earth that are exposed to weathering processes and evaporation processes, those are the sedimentary rocks. So how do sedimentary rocks form? Since we're going to talk about those next, here's the deal. Well, first of all, you got to have a rock. You got to have an igneous rock. And igneous rocks are going to be the first to form because those are the ones that are going to cool out of magma. And then what's going to happen is they're going to be attacked. The ground might uplift, making them more vulnerable to attack. It's kind of like if you had a piece of sidewalk lifted up, you would tend to stumble on it. Well, Mother Nature sees something lifted up, it's going to attack it. Like when the layer cake of the Colorado Plateau area lifted up, Mother Nature said, ha, 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 that's going back down. Because Mother Nature's objective, cut everything down to sea level at any cost. So what's going to happen if something's sticking up, if it gets uplifted, it's going to be beat down by weathering and erosion, it's going to be pieced up. We call that forming sediments. Now, what's going to happen is those sediments, well, they're going to back into a rock. How are they going to do that? They're going to get deposited. They're going to get buried. They're going to get compacted by Mother Nature. And they might even get cemented with a little bit of evaporation process going on, and then they form a sedimentary rock. You're asked in the final exam, hey, give me 4 words for how sediments turn into sedimentary rock. It's right here. You don't even have to think, which might be good. Deposition, burial, compaction, and cementation. How do sediments form sedimentary rocks? And then, who knows, they might get weathered and eroded after they're a sedimentary rock, and then the whole thing starts again. But it all starts off, initially, with igneous, and later on we'll talk about metamorphic rocks. It all starts off with igneous rocks. An igneous rock might form in a metamorphic rock, which might get attacked. An igneous rock may form into a sedimentary rock, which might get attacked. The igneous rock itself might get attacked by weathering and erosion processes forming sediments. So let's go to the sedimentary rock chart. Here it is. An easier chart than our last one, actually. I'm going to turn off the lights so we can see this better. So here it is, the sedimentary rock chart. And what do you have? You have inorganic land-derived sediments. In English, pieces of rock that had been pieced up because a rock has fallen, got crushed by Mr. Glacier, got run over by a stream, something beat up the rock. And you started off with a rock that has been broken up into pieces. Your granite countertop at home, you drop something heavy on it, it shatters it. Mother Nature, in essence, does that with other rocks. So what you get is you're going to get pieces of quartz, you're going to get pieces of feldspar, you get pieces of clay minerals. You're going to have all these pieces. Now, what size of the pieces, actually sometimes referred to as class. Hard word to say. Class. C-L-A-S-T-S. C-L-A-S-T-S. Class, or pieces. There's a clastic word. Fragments. Okay, if they're this size, sand, they're between those numbers. Well, guess what? When they are compacted and cemented together by nature, they form what's called sandstone, and that's what sandstone looks like in your reference table. If they're silt size, they form siltstone. If they're clay size, which we can't see individual pieces of clay, they form shale. Okay? If they are made up of pebbles and cobbles and stuff like that, they make up a rock called conglomerate. Let me just show you what I mean here. Okay? Right here, I have a piece of conglomerate. Okay? Conglomerate's right here. Conglomerate's got pebbles in it. It's got some clay in it. It's got everything in it. What does it say on the chart? It says in the chart it's got everything. Okay? It's made up of a conglomeration. Conglomeration of a bunch of different things. Of course, sandstone would be all sand, siltstone would be all silt. Sometimes you get a combination thereof. And then as far as shale, shale usually looks grayish, okay, sometimes brownish. And shale, I mean, I could snap this, which I'm not going to. Okay, shale breaks up easy because, and often, shale is only made, look at this, okay, shale is only made by compaction. And it may split easily because it's made up of clay. And the thing is, though, clay is what settles to the bottom of lakes, possibly in the bottom of the ocean. And if you're something that has died, you're going to fall into that slime, that slurry of clay particles. Now all the water goes away, and after the water goes away, well, what's left? What's left is let me get a piece of shale right there. Here's a piece of shale over here. I'm back, guys. Hi. Here's a piece of shale with a little potato bug kind of guy in it called a trilobite. Trilobite because it has 3 main parts, look like little potato bugs, and they were crawling through the mud. They like to do that. Okay, and you can see all the layers of clay packed together. And the thing is, shale often has fossils in it. You can bet if a rock has a fossil in it, it's most likely, not always, most likely a sedimentary rock. And if it's a land-derived rock with fossils in it, it's most likely shale. They're the ones that usually have the fossils. Although sandstone can too, so can siltstone, so can conglomerate. Okay, but that's land-derived. Now, what other type of sedimentary rocks are there? They're chemically and organically formed sedimentary rocks. Okay, what's the main thing forming these guys? Crystals formed from precipitates and evaporates. I'm going to put this in English for you. Okay, this is red cherry Kool-Aid that you are enjoying. And you have a whole glass of red cherry Kool-Aid. And now what's going to happen is you're not going to finish it and you're going to leave it on the deck. You left this much cherry Kool-Aid on the back deck and it's summertime, it's in August. And you forget it there for like 3 days. Then you go back to the deck 3 days later like, hey, I left that glass there. Or your mother yelled at you for leaving the glass there. Will there be any evidence in that glass that you were drinking red cherry Kool-Aid? You might say no. Well, I'm going to say yes. There's definitely going to be evidence. There's going to be no more liquid because what happened to it? It evaporated. But then there's this thing called the precipitate. What's the precipitate? It's the goopy stuff left in the glass, little crystals of red sugar that have been left in the glass, evidence that you were drinking red cherry Kool-Aid. A film on the glass. Well, you get enough of that film, you get enough of that precipitate, the stuff left over after water evaporates, and you get a rock. What kind of rocks do you get? Well, sometimes you get rock salt. You get enough water evaporates, has enough salt in it. This is directly from Poland. This is a piece of rock salt. Now, how's rock salt different than halite, which is called salt? Halite is pure. It's a mineral. Rock salt is contaminated with other things besides just the halite. So it makes up rock salt. Sometimes you have gypsum, or what's called gyprock. Gypsum is the mineral, gyprock is the rock. So here it is, they call it rock gypsum, or gyprock. So big deal, you get a bunch of rock gypsum. This stuff is in every house in America. It makes up what we call drywall. It's in the walls of your house. You punch a hole in the wall of your house, you put a nail through it, you're gonna get white chalky stuff. That is made by this stuff being in the water, the elements that form gypsum being in the water, with sea creatures being in the water. Yes, your walls are made up of sea creatures as well. And then my favorite sea slimer, you're going to get calcium carbonate settling to the bottom of the ocean, forming a sea slime. And that sea slime looks like this. It's a big hunk of rock. Very, very, very solid rock. Sometimes parts of actual coral reef formation where the life actually makes the rock. Excuse me. In fact, what we say with limestone, we separate it from just precipitates from evaporates because there's other things going on. It actually is made up of the mineral calcite and it precipitates of biologic origin. And sometimes even cemented shell fragments. Evidence of life all over it. Look at all the fossils in this. This is a gooey slime at the bottom of the ocean that has so much life concentrated in it. Like I said, often part of coral reef, and it's just this chemically and organically formed sedimentary rock that is probably the #1 form of sedimentary rock out there making up the landscape. Again, it's called limestone. Sometimes I refer to it as slimestone. Another sedimentary rock that people don't think of as sedimentary rock is coal. Now, there's different forms of coal, but one of the main forms is called bituminous coal. And that's just a bunch of packed plants together. Sometimes people get that confused with obsidian, but obsidian is much harder, much shinier, and coal that we use to burn for energy, hopefully not so much anymore. Okay, definitely not so much anymore in New York State, only one coal electric power plant that I'm aware of. But the remains of plants from around 200 million years ago that got squeezed in rock, and since it happened at or near the Earth's surface, since it was made by this compaction, maybe even a little cementation, but when it comes to plants, just really compaction, it fits the bill to be called a sedimentary rock. So in essence, 2 types of sedimentary rocks, just like there were 2 types of igneous. With igneous, there was either intrusive or extrusive. How rapidly the magma cooled decided what type of intrusive, extrusive they were, along with the composition of the magma. With sedimentary rocks, let me get my pointer, you either have what's called land-derived pieces or sea stuff, where evaporation and precipitation is involved. These rocks also tend to be monomineralic, which means they're just made up of one mineral. Rocks that are land-derived with pieces tend to be polymineralic, more than one. Follow the chart and you'll get your answer every time.